So for question 2, we're told that we have an item that costs 80,000 and then we have two payment alternatives. So alternative 1 makes an initial down payment of 20,000 and then make another payment of 40,000 at the end of year 2, and then make one last payment after 10 years of 120,000. And we're asked to draw the cash flow diagram, and then we're also asked to use the net present value to determine which one of these two is the better option, right? So let's start with the alternative 1. So alternative 1, we start with a down payment of 20,000, then after 2 years we make a payment of 40,000, then after 10 years we make a payment of 120,000. So what we're trying to do with the net present value is, as far as I understand it, right, we're trying to calculate what each payment would be in today's money. So interest has been applied to this amount and interest has been applied to this amount as well. So we're trying to figure out in today's money what would these values be, right, without the interest. So for year 1 we make the payment like today, so there's no interest applied to it, right? So we'll take it as is, but then for this 40 we need to discount it. So we need to go to our table over here, and what we're given is the future value. So this is the value that has interest applied to it. Again, as I understand it, might be wrong, but yeah, so this is that value, the future value. So we need to find the present value, and we're given the future value. So this is present given future value, and then our n is 2 because we are d at 2. So 2, and then that's our factor. So we're going to multiply it by 0.7972. Cool. Then we go to this payment made at year 10. It's going to be minus 120,000 multiplied by the factor for year 10. So you go to n is equal to 10, and then we want present value given future value. So that's going to be your factor. Then cool, you'll get your net present value. Then for alternative 2, we're told that we don't make an initial down payment, but we make a first payment of 65,000 at the end of the second year, while an equally yearly payment of 8,000 is expected to be made from the end of the third year for a period of 9 years. So we start with the first payment of 65,000 at the end of year 2, and then from year 3 and then continuing on for 9 more years, we make a payment of 8,000, right? Cool. So there's two options, there's two ways of doing it. You could do the method that we did here, where you start, rather, how do I explain this? You like add each one and you multiply by its own factor, right? So this 40,000 was made, this 40,000 rand payment was made in year 2, so you multiply by the factor for year 2, and then you carry on like that. So for this one, 65,000 was paid in year 2, so it's going to be 65,000 multiplied by the factor for year 2, and then again you're going to say a payment was made of 8,000 multiplied by the factor for year 3, 8,000 again multiplied by the factor for year 4, 8,000 again multiplied by the factor for year 5, so on and so forth up until year 12. You could do that, or we could be smart and group these together. So over here we have annuity, which means consecutive payments, like the same consecutive payments for what? No, the same amount for consecutive years. I think that's the correct way of saying it. So we're paying 8,000, right? consecutively for 9 years. There's no gap in between. There's no like change in amount. It's like the same 8,000, 8,000, 8,000, 8,000 for 9 years. If there's like a gap in between or whatever, then that's not annuity, right? So for example, if we had 8,000, 8,000, and then we skipped year 5, but then year 6 we carried on paying the 8,000, then you'd have annuity between year 3 and 4, but not year 5 because there's a break. It's not consecutive. Then from year 6 up until year 12 you would have annuity again. So yeah, hope that makes sense. Cool. So we have annuity here. So we can do a clever trick with that. So we're gonna start with our first payment, 65,000, year 2. So 65,000 multiplied by the factor for year 2, which is gonna be the same factor we got over here, right? And then subtracted by this 8,000 multiplied by its annuity factor. So on our table, we have annuity for 9 years. So we're going to go to n equal to 9, and then we're going to look for the present value given annuity. So P given A, that's going to be 5.3283. Cool. So when doing annuity, you multiply by the annuity factor, then you also need to multiply by the factor for the previous year, the year before the annuity started. So annuity started on year 3, we need to multiply by the factor for the year previous, which is the 0.7972. Cool. And then calculate that, then our conclusion will be that the alternative with the lowest NPV is the better alternative for cost saving. So because we're paying, we want to pay the least amount. So the one with the lowest net present value is the better one. And then that's for something that's cost dominated. So when something is cost dominated, the NPV will be negative. And then when something is what's the other one? I don't know. Is it income dominated? That sounds wrong though. But yeah, when it's like, when the arrows are up mostly, or when the NPV is positive, then the better one will be the more positive one, because that means you're earning more money. If you choose the more negative one, that means you're losing more money, which is bad. So you choose the less negative one. Cool. Hope that makes sense.